Hi dear, this is Kamal Sarma again. Today I am going to discuss about bending moment and shear force diagram for more complex loading. So let us draw the loading. This is pin supported. There are two reactions there. This is A point, this is B point. B is roller supported. So here vertical reaction, we call it RB as a one reaction. That's the reason I'm calling it RB. But here VA and HA. One is the vertical reaction, another is the horizontal reaction. Let's look at from here to here. We assume this distance is 20 either meter or feet. You can use both. The number is same, but this meter and feet are not same. Okay, so 1 meter equal to 3 feet and 3.4 inches. This is the relationship between meter and feet. That's the reason I am saying they are not same. Similarly, if we use say SI system for loading, say there is the distance is, we assume it is 10 and this loading is say 2 kilonewton per meter, or you can take it is kip per feet. Again, these two are not same. The 10 kilonewton equal to 2.25 kip. But I am keeping the number same because my calculation will be easier. So now let us see the other loading. So here to here, say it is 5. This is also 5. Here the load, there is a load there at this point, it is say 20 kilonewton or 20 kip. This is an angle, 60-degree angle. It's an angular direction. And there is another load, the vertically downward load, that is here we are applying, say it is 10 kip or 10 kilonewton. Okay. Now, what is the shear force diagram? First of all, we have to find out the component of this, the inclined load, in a horizontal direction and a vertical direction. The horizontal direction, it has a component. We can find out directly what is HA. HA equal to summation of horizontal force is 0. Summation of, this is the equilibrium equation, one of 3. So then HA equal to 20 sine of, is going this way, sine of 60 degree. Oh sorry, this is cos of 60 degree. This is the angle theta is cos. So 60 degree, it is 20 times 0.5 equal to how much? 10 kilonewton or kip. So this is 10. Now this force is axial. So always remember, axial force doesn't cause any bending or shear force. It doesn't do any bending moment. It doesn't have any bend moment or shear force. The shear force is always x transverse to the, you see, transverse to the section. Like that, shearing. And bending moment is try to bend. So that is the forces acting this way or that way, try to bend, and another is just shear it. Now, what is the component, vertical component of this one? Let us calculate. This is 60 degrees. So this value will be 20 times sine of 60 degree. Sine of 60 degree is 0.866. So this value will be 20 times 0.866, 17.32. So this is 17.32. So this 17.32 only will be active for bending moment and shear force. Now next step is to find the reactions, V vertical reaction, because horizontal reactions we already calculated, VA and RB. Let us take the RB, take moment about this point, all the forces, okay. See, this force is, if you take this, hold it here, if you push it, it will be a anti-clockwise moment, and all these vertical downward force will cause clockwise. So our convention is, for moment, this is all positive. If you consider from right to left, anti-clockwise is positive. If you consider from left to right, it is clockwise is positive. Similarly, this is a sagging moment. You try to bend like this, and this is a negative moment. You try to bend like this. If you consider this one from right, this one from right to left, this clockwise is negative. Similarly, also consider from left, this one, say left to right, if you reactions were like this, then this would be a negative moment. So now let us take, don't get confused, okay? Let us consider this one. Clockwise moment is positive. So let us take RB times 20, that is equal to 10 times 15. From here to here it is 5, here to it is 5, acting at the middle. Then plus, you have got the UDL 2 kilonewton or 2 kg per feet times 10, so it is 2 times 10. Where it is acting? The resultant will act here. So it is at from here, the distance from here to here, 5 plus 5 plus 5, 15. So what is this to right hand side? The right hand side is 150 plus, there's one more force we did not consider, 17.32. We have to consider that also, because I didn't see that. So plus 17.32 multiplied by 5 from distance to there. So what is the total force? 150 plus, so it is 300 plus 17.32 times 5, 17.32 multiplied by 5, 86.6. So total is, if you add up all these, this is 150 plus 300 plus 86.6, 536. Okay, this is the, then your RB is your 536.6 divided by 20. So this will be your 26.3, 26.83. So this is your 26.83. Now let us see what is the value here, VA. VA, we have to take help of the third equilibrium equation, summation of vertical force is equal to 0. So what is the total force there? All downward, 17.32 plus 10, then plus 2 times 10 is 20, right? So all together, all this vertical downward force equal to 17.32 plus 10 plus 20, 47.32. So what is this VA? VA equal to 47.32 minus 26.83. So this force is 20.49. So this value is 20.49. Now let us draw the shear force. So shear force will be, this is the baseline. Shear force at this point is you see here at this point there is no force, this is going up. So our convention for shear force is, if you go from left to right, if you calculate the value from left to right, from this way, this is your positive and downward is negative. If you consider from right to left, your this is your negative and this is your positive. If you consider from right to left, calculate the value. Upward negative that side, upward positive this side, downward positive there, downward negative there. Depends on how you calculate the values, but result will be the same. Okay. Now it is from here to here. This is your 20.49. There is no force in between. Okay, no force. So this will remain constant going up to all the way here. Just left of this point, it is still 20.49. But as soon as it reaches this point, going just right of this 17.32 comes in. So it will be reducing this number. 20.49 minus 17.32. So 20.49 minus 17.32, 3.17, but still positive, still positive. You see, this is negative, this is positive, so it is coming down, but this value is your 3.17. There's no load in between here, so this will continue with that. As soon as it arrives just left of this load, 3.117 is the net unbalanced force at that section. As soon as it crosses this one, these loads 2 kilonewton per meter or 2 kip per feet will be acting. So when this UDL is there, the bending moment is linear. I told you earlier. So it is gradually reducing. So it is going in a reducing in a constant rate. So it will be acting, it will be like this up to this point. So this is, what is this value? So up to this, what is this value here? What is the shear force there? So it is 3.17, it is positive still, then minus 5 times 2. 5 times 2 is 10, right? So negative 10. So your 10 minus, it is 6.83 negative. So this value here at this point, just left of that, remember 6.83, this is a negative value. Okay, then suddenly on the left hand side, this is the value just left of this, just right, this 10 kilonewton or 10 kips comes in. So increase this value. What is the value there? So 10 plus 6.83 to 16.83 here. Okay, now again these loads are constantly acting downward. Downward force we are considering from left to right. Downward is negative, so negative 6.83, then plus negative 6.83 minus 10, it is here, it is 16.83. Just right of this force again reducing, so it will be again like this, parallel to this line, because the rate of decreasing is same. These two lines are parallel. What is the value here from here to here, just left? 16.83 minus 2 times 5, 10. So this is a 26.83 at this point. This value is 26.83, negative 26.83. Then suddenly this force, the vertical force upward is acting. Again the same convention, upward positive. So it will go up with the 26.83, neutralize this value, merge with the baseline. So this is your negative shear force, this is your positive shear force. At this point is the shear force changes is signed. I told you when the shear force changes is signed from positive to negative or negative to positive, there the moment will be maximum. This is the important point. Your maximum moment of bending moment will be maximum at this point. Let us draw the bending moment. So bending moment will be, so here, what is the moment here? One thing you see, this is a constant line. So when shear force is constant, bending moment is linear. It will be like this. Without finding the value, we can know, you know what this is. This will be a linear number, slanting line, like this. So what is the value? It is your 20.49. So it is your RVA times distance. There is no other force there to cause a moment here, because this force will pass through. This will not cause movement at this point. So VA times 5, this is equal to 20.49 times 5 equal to, let us calculate the value, 20.49 multiplied by 5, it is 102.445. .49 multiplied by this distance 5, 102.45. I check the double check. You always double check your numbers. You see, that's important, because first time you may make a mistake. So always it is better to check it twice. So what is the moment at this point? Now here the moment is, this force will cause a moment reduce in the moment. You see, reducing the effect of moment, because this is acting clockwise, this is acting anti-clockwise. So at this moment you have a linear but with a little less slope, because effect of two force. Had there been no force, it would have continued with the same slope, but its slope is reduced because of the other load is acting in an opposite direction. It is clockwise moment, this is anti-clockwise. About this point, this is clockwise, and this will be causing anti-clockwise. So both opposing, so the slope will be reduced, and this value will be, at this point, find the moment, 20.49 times 10. This load is times 10. This is the load. VA is 20.47 times 10 minus, because this is clockwise, this is anti-clockwise, 17.32 times 5. What is the value? 20.49 times 10 minus 17.32 times 5. The 118, this value is 118.3, this point, from here to here. This moment is 118.3. We take moment about this point, at this value, at this middle point. So it will be like this value. Then see what happens. This is linear from here to here with reduced slope. Slope is reduced because moments are acting. One is clockwise, another is anti-clockwise. They are reducing. That's why the slope is little bit reduced than this one. Okay. Then at this point, you have further it is reduced. It is be going down. What rate? So this moment will be parabolic. At this point, you have a maximum moment. After that, it will be going down like this. parabolic the maximum here under this load, this one. This is maximum. What is this value? We can calculate it. What is this value? You do not know, but you can know one thing, that from here to here, you can calculate that very easily. Similar triangle condition. So this is 3.12, 3.17, and this value is your 6.83. Okay, and say consider here to here is 5, so consider this is x, this is x. What is this value x? So we can similar triangle condition, so this divided by this, so 3.17 divided by 6.83 equal to x divided by, from here to here total length is 5, so from here to here the distance is 5 minus x, so divided by 5 minus x. So what is x? You take it other side, so 6.83x equal to 6.83x cross multiplication, so 3.17 times 5, then minus 3.17x. So your x is, what is your x? Let us calculate the x. So 6.83x, take it to the other side, 3.17x, add these two, then this will be 3.17 times 5, 3.17 times 5, so 15.85. Okay, so your this side total is 6.83 plus 3.17, this is 10, 10x is equal to 15.85, right? Then what is your x? X equal to, divide this, 1.585. So this distance is 1.585 from here to here. 1.585. You got it? Similar triangle condition. Okay, so this divided by this equal to this divided by that. So so now what is the moment there? Maximum moment. We can easily calculate that. So what is the moment? So this is your VA times from 10 plus this distance. This distance is 1.585. VA times 10.1.585 minus this 17.32 times from the here 5 plus 1.565, it is 6.585. And there's a little part, so minus, what is this value? So your intensity is 2, so 2 times 1.585 Where this load is acting? Just at the middle, half of that. So it is 1.585 divided by 2. So this is the moment, maximum moment. So it is, and VA is, we can write the VA is nothing but 20.49. 20.49, then this, then minus that, plus that. So this is the value here. So let us calculate the value. So 20.49 multiplied by multiplied by 11.585, right? $237.377, again 20.49 times 11.585, 237,377, then minus this value 17.32 times 6.585 minus 114.052 minus this value. So 1.585 times 1.585, these two will cancel. You don't need to multiply. So minus, it is 2.51. So what is the total value here? What is the maximum value there? We just calculated. We just simplify that equation. So this value will be, so what is these two negative numbers? 115, so 114.052 plus 2.51. Subtracted 237.377. So it is 120.815. So this is 120.815. This is the maximum moment, and it is slope, it will be going down like this. So from here it is, things are easier, it is slope, that's why it is going there, then it is going, it will be further going down. There is a crease there. This is a crease because this is linear, but it is further, there is a constant load, so it is not a smooth curve. There is a crease there, then again it is going down. Got it? So, and it is all positive moment. What is the value moment there? Let us calculate that. What is the moment there? Because the moment will be, these forces will not cause any moment, or you can directly find out what is the moment from here to there, from right side. It will be easier. So right side we consider is the clockwise, the anti-clockwise is positive. So this reaction is from here, this moment is 26.83 times 5 minus this load will be causing clockwise. This will be anti-clockwise is positive. So our convention is like this. This is positive. Clockwise, if you consider from right, clockwise is Anti-clockwise is positive, anti-clockwise is positive, and clockwise is negative. So 26.83 times 5, and from here to here, because we are considering from right, because there are less number of forces, less number of forces. It is easier to calculate. Less number of forces. So what is the moment there? So this force will not cause any moment because it is acting through that point. Only moment will be caused by this part. So it is 2 times 5, and it will act somewhere here. So 5 upon 2. So this value is 26.83 multiplied by 5. So 134.15. Let me calculate again. 26.83 times 5, 134.15 minus, this 2 will cancel. So it is 25. So this value is 134.15 minus 25. So it is 109.15. So this value is 109.15. See, this is less than that. 120.813. This is less. This is higher than this value. 118.3. So this is the maximum. This is your bending moment diagram, all positive. There's a crease there because of the concentrated load. So this is your BM diagram. This is your shear force diagram. Okay? This is all about. It's a complex load, but only thing, don't get scared. And you know how to calculate the maximum by similar triangle condition. This is very important. You should know that. How to find out the x distance. Once you find the x distance, add up the distance and things will be easier. When you see the lesser number of force in a member, then take that. Don't go all the way from left. There are more loads on the left side, but less loads on the right side. It's easier to calculate the moment from the right side. Okay? And I'm done with today's work today. This is all for today. Okay? So do this example by yourself and solve some other problem similar to this. Take the example, solve problem from a book and see if you can find out this method using this way. And I'm sure this will be much easier than many of the discussions on bending moment and shear force and bending moment diagram on your books. I am using a different procedure, different technique. You may not find in the books, but this is the right way of doing it. You can understand it very fully. When I taught in Assam Engineering College, I used this procedure to how to find out the bending moment and shear force diagram. And probably you are taught by your professors. Some of them are my ex-students. They learned this through me by this method. It's an easier method to find the bending moment and shear force diagram, and they are using this technique. I wish you good luck. Thank you very much. Thanks for watching. Have a good day. Bye.